And welcome to our practice set on literal equations. Don't forget to like and subscribe if you find this video helpful, and drop me a comment to let me know if you have questions. A well done practice set will often lead to other questions. What would happen if? So if you're having one of those questions, please drop me that question in the comments and I will get back to you with an explanation video. Let me know what you'd like to see. Pause the video to work these problems on your own and then come back to check your work. So for this first one, the first formula is the volume of a rectangular prism. And this is a very common formula where you have the length, the width, and the height. Sometimes you'll see instead of length, width, and height, you might see like a base and height and width, or base length. You might see depth as a dimension. We will sometimes alter the words that we use to describe the volume, but it's always the three primary dimensions. So you might see length and width, or base and height, or again, like depth might be thrown in there. So don't let that throw you at all. And we are asked to solve it for L. And so we have volume is equal to length times width times height. You can do this in 2 steps if you want. So I have seen students do that where they say, okay, it's being multiplied by the W, so I'll divide by the W. And that leaves them W over W is 1. And then they'll divide by the H. That gets a little bit messy and you don't need to do it. So you can recognize that the length is being multiplied by WH kind of all together. So if you want to like think of it like that, okay? And then to get the L by itself, you would divide by WH. So that works just as well. WH divided by WH is equal to 1. Again, we never, ever, ever want to lose sight of why things are canceling out. So we have on the left, volume is equal to volume over WH is equal to, and on the right, we have the L. Or if you want to switch the order, you might be a little bit more comfortable with the order like that. So that is the first one, solving it for L. The second one here, this is a formula for perimeter, and I am not a big advocate of formulas for perimeter. I'm just not. I think it's better to know the definition of perimeter, but essentially perimeter is the distance around the outside. And so if you were like, I use the analogy, if this is like a museum and you're the security guard and you're going to walk the perimeter, make sure nobody's breaking into the museum. The perimeter would be how far you're walking as you go around. And so you would walk L, and then you would walk W, and then you would walk the length again, and then you would walk the width. And then so that means you are walking 2 lengths and 2 widths. And so the perimeter distance around the outside is 2 lengths plus 2 widths. That's where that comes from. The reason I'm not a big advocate of the formula is because there's all different kinds of shapes and they don't all necessarily have length and width. So if you were looking at like a triangle, there's no like length and width to a triangle, but the perimeter, the definition would be the same. So if this were a 3 by 2 by 4, 3 by 2, 3, 4, gosh, that was terrible. Side lengths 3, 4, and 2. For that, you could find the perimeter by just adding them all up. So that's why I'm not a huge advocate. So going back to the problem though, so we do have the formula here. We've got 2L plus 2W, and we are asked to solve for the W. So we've got the 2 multiplying it, and then we have the 2L being added on. I can get rid of that 2L by subtracting 2L or by adding negative 2L, whatever you liked better. The adding the negative 2L is a little bit nicer because you could just like fit it on the left side there. That's kind of where I put it. So you're adding negative 2L. On the left, we have negative 2L plus P right here. Those are 0. And 0 plus 2W is 2W. And then that is multiplication. So I'm going to go ahead and we'll write it down. 2 divided by 2 is 1, leaving me with the W all by itself. And you can write it as negative 2L plus P over 2. You might have, if you had done the subtracting on the other side, you might have it written that way, P plus negative 2L. You might have it written as minus the 2L. You could also split it up and do P over 2 minus 2L over 2. And then that would cancel out and you'd have P over 2 minus L. So a lot of different ways you could write the answer. I think I gave you, how many ways did I give you? 1, 2, 3, 4 different ways of writing the answer. All of them would be equally correct. So hopefully the way that you wrote it is one of those ways. But if it's not, there could be some other ways that you could write that. You can drop a comment, just say, hey, I wrote it this way. Is this correct? Also, I'd be more than happy to help you out with that, just to make sure that whatever form you chose to write it in is a correct form, or if it's not correct, that we fix it. This formula here, this is kinetic energy. This is a physics formula. And so kinetic energy is equal to 1/2 the mass of an object times its velocity squared. And we are being asked to solve for m. So I'm going to approach this one the same way that I approached one in the lesson, where if we are multiplying by 1/2, I can get rid of that multiplication by 1/2 by multiplying by 2. And if I multiply one side by 2, I have to multiply the other side by 2. 2 times k is 2k. And right here, 2 times 1/2 is 1. And so 2 times 1/2 is 1. And 1 times mv squared is just mv squared. And now this is multiplication right between the m and the v. So we'll divide both sides by v squared. V squared over v squared is 1, which is why it cancels. And I have 2k over v squared, or if you'd like to rewrite that, you might rewrite it with the variable on the left. That is completely up to you. You might be wondering, how do I know the difference between volume and velocity? We used a V for both. Sometimes I've seen volume done with a lowercase v. Usually volume is an uppercase V and velocity is almost always a lowercase v. But even if it weren't, you would usually have a context to the problem. So if you're solving a problem with energy, the volume is not even a thing that you would be concerned about. Problem number 4, we have 2x plus 3y is equal to 6, and we are asked to solve for y. So I see that I am adding 2x. I can get rid of that by adding a negative 2x or by subtracting 2x. Over here, 2x plus negative 2x is 0, and 0 plus 3y is 3y. And over here, we've got the 6 plus negative 2x. Now we have multiplication, and we undo multiplication with division. And I'll go ahead and do this in the 2 separate ones. So 3 divided by 3 is 1, and 1y is y. 6 divided by 3 is 2. And I'm going to go ahead and move that out of the fraction there because I like it better. But if you're not sure what I did there, please go check out the video. So if you just jumped to the practice problems and didn't watch the video, I do talk about that in the instructional video, like why we can do that. Now you might see this with it written in the other order, and there's a reason for that that's coming up very soon, like the next lesson, maybe the next 2 lessons. So we'll see why that is a popular way to write it, but it is not required for solving for y. Solving for y just means you get the y by itself. And problem 5 here. So for problem 5, we have what is this? This is the volume of a cylinder. So volume of a cylinder. So here's my cylinder. You find the area of the circle. The area of the circle is pi r squared, and then you multiply it by the height, and that tells you the volume. And we are being asked to solve that for h. So the most straightforward way to do this is to recognize that, yes, it's being multiplied by 2 things, but we can undo that multiplication in 1 step by dividing by two things. So that's dividing by pi r squared. Pi r squared divided by pi r squared is 1, which is why they cancel out, leaving me with h, and the left-hand side is v over pi r squared, or if you want to switch the order of that to make it a little bit more comfortable to read, that is 100% you, whatever you want to do. And the last problem, the length of a rectangle is twice its width. The perimeter is 24 centimeters. Find the length and the width. So this one, let's draw a picture. Drawing a picture is never to be underestimated. So we've got the length, we got the width, we got the length, we got the width. We know our formula. And we know that the perimeter is 24. Now, what else we know is that the length of the rectangle is twice the width. So whatever the width is, the length is 2 times that. So I'm going to write that out. Whatever the length is, it is 2 times the width. Whatever the width is, oh gosh, I think I said it all backwards. The length is, it's twice the width. Whatever the width is, the length is twice that. So over here, the length is double whatever the width is. So what I can do with that is I have like, this is equal to 2w equal to 2w. So my perimeter, I could now write as 2w plus w plus another 2w plus w, which is how many W's? 1, 2, 3, 4, 5, 6 W's. Or you can do that right here. And you can say, instead of the length, L, we can plug in 2W. And 2W, 2 times 2W is 4W. 4. And 4W plus 2W is 6W. Okay. Either way, there is totally fine for how you'd want to come up with that. That is multiplication. So we can undo that with division. 24 divided by 6 is 4. 6 divided by 6 is 1. So we have 1W. So the width is 4 and the length is 2 times the width, which means the length must be 8. Now you can double check that. So this is where the picture might come in handy. Okay, so I'm going to go erase these. I'm going to just double check my work here, because why not double check your work? So we have 8, we have 4, we have 8, and we have 4. Is it true that the length is twice the width? Why, yes, 8 is twice 4. And then we can look at the perimeter. So the perimeter here would be 8 plus 4 plus 8 plus 4. I'm going to add this kind of out of order. 8 plus 8 is 16, and 16 plus 4 is 20. That's why I did that. I kind of combined that to get the 6. And then 20 plus 4 is 24. So I know that meets both of the requirements. So I'm confident I have a correct answer.